composition of trig functions with double angle identities. All right, so with these problems, I'm going to tell you something I have told you many, many times already in the course of this course. So you have a problem like this. Find the exact value of sine of 2 cosine inverse of negative 2/3. And you have an inverse trig on the inside. Whenever you have inverse trig on the inside, set inverse trig equal to theta. It's the trick that works all the time, the constant trick. So you have this thing inside here, it's a trig inverse. We're going to say it's theta. We're going to say, hey, cosine inverse of negative 2/3, that is theta. And when you say that, then you can rewrite this and say, well, if cosine inverse of negative 2/3 is theta, that means cosine of theta is negative 2/3. This allows you to rewrite this statement right here. Sine of 2 cosine inverse of negative 2/3. Well, we said cosine of negative 2/3 is just theta. So I can replace this with theta. And what I'm really looking for is sine of 2 theta. And sine of 2 theta, we have a formula for that. It's 2 sine of theta times cosine of theta. 2 sine theta, cosine theta. So really what we need sine of theta, we need cosine of theta. Once we have sine of theta and cosine of theta, we just plug them into the formula. So we have to do a little bit of trickery here. We have to do a little bit of thinking. First things first, we need to, figure out all 3 sides of the triangle. And we also need to figure out what quadrant theta is in. We are given cosine of theta, right? Like that came with this. We have this. This right here is negative 2/3. It came from the problem. So what we actually need is just sine of theta. Just sine of theta. Now, we know that theta came from cosine inverse. And that means that there is only there's a restricted range, right? Cosine inverse only, oops, not that side. Cosine inverse only outputs angles in quadrants 1 and 2, right? From 0 to pi. That's the range of cosine inverse. So we know that theta will not be in quadrants 3 or 4. Theta has to be in quadrants 1 or 2. We know that cosine of theta is negative. So it can't be in quadrant 1, right? Because we know all students take calculus. We know that cosine is positive in quadrant 1, so it has to be here in quadrant 2. Theta is in Q2. Again, what are we trying to find? We're trying to find sine of theta. That's the only thing we have left to fill in this formula. So we need sine of theta. What do we need for that? Well, sine of theta, that's equal to opposite over hypotenuse, right? So I'm going to come here. Cosine is adjacent over hypotenuse. Boop, boop, boop. So we have our adjacent, our hypotenuse. The opposite side is going to be the square root of hypotenuse squared minus adjacent squared. So that's going to be square root 5. That'd be 9 minus 4, square root 5. Sine is positive in quadrant 2, so this is going to be positive. And then let's see, opposite, square root 5. over hypotenuse 3. Sine is square root 5 over 3. Log the square root 5 over 3. Plug those all in. You get negative 4 over square root, not over, negative 4 times square root 5 all over 9. And that is sine of 2 theta, which again is sine of cosine inverse of negative 2/3. It's your answer. No, 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 no. Not so bad, right? All right, we'll do another one. Here we go. Rewrite cosine of 2 tan inverse of 3u over 7 as an algebraic expression in u. Again, this looks silly, but all you're doing is the same thing that you did here, but with instead of numbers only, it has some letters, some variables in it. No big deal. You got this under control. So same idea, set that inside equals a theta. So you have that tangent inverse of 3u over 7 is equal to theta. Rewrite that as regular trig. Tangent of theta is equal to 3u over 7. That means that what we're looking for, cosine of 2 tan inverse of 3u over 7, is actually cosine of 2 theta. And you have choices for this one, which formula you use. I'll scroll down to these formulas here. Where are they? You can use any of these formulas. I don't know. I always choose this one. This one requires you finding cosine and sine, so that's like why I don't bother with that one, but it doesn't matter what you do. I'm gonna go ahead and I like to choose this one here, 2 cosine squared x minus 1. But no, screw it, I'll do this one. They're all gonna give you the same thing anyway. Cosine squared minus sine squared, right? Yeah. Why not? Why not do something new? Cosine squared theta minus sine squared theta. That means that I need both of those. I need cosine squared theta. I need sine squared theta. I have opposite is 3u. Adjacent is 7. Hypotenuse will be the square root. This is really important when you do this. So the 3u squared plus 7 squared, it's really tempting. This is a square. It's really tempting when people do 3u squared to make it into 3u squared like this. But the square actually belongs to both. It gets distributed to both of these. So it's actually 9u squared. So the hypotenuse is equal to 9u squared plus 49. It's disgusting looking, but it's fine. So cosine squared theta, cosine of theta. And with these variable ones, you don't need to worry about the quadrant that it's in. Don't worry about it. So cosine of theta, adjacent over hypotenuse. So 7 over square root 9u squared plus 49. And sine of theta is equal to opposite 3u over hypotenuse, square root of 9u squared plus 49. And we just plug those into this formula here. So we're going to take cosine squared minus sine squared. This becomes 49 over 9u squared plus 49 minus 9u squared over 9u squared plus 49. And they have the same denominator now, so you can combine this into 49 minus 9u squared all over 9u squared plus 49. And that is cosine of 2 of tan inverse 3u over 7. Boom. Okay. So that is these composition problems. The big idea, set the middle of it in the inverse trig equal to theta, and then run the rest of it through it. Set it equal to theta, then you know information about theta, find the opposite adjacent hypotenuse, figure out what formula you need to use. From that, find the appropriate parts from theta, plug into the formula, simplify, and there you go. And I will see you in the next video. Bye.